Hey everybody, Mr. Barry here. We're in Unit 3 talking about solving quadratic equations. So piggybacking off of the previous different Nearpods that we did and videos that we did referring to the different things of factoring, we're going to combine some ideas here. In this video, we're going to be checking for the GCF as well as doing our ABC method, which is factoring that quadratic trinomial after already pulling out the GCF. So we're going to combine those two ideas. I got 3 problems up here. I'm going to try to do them one at a time here for you. And we can kind of compare and contrast different ideas that are involved there. 3x squared plus 18x plus 24 is equal to 0. Do remember that for all of these problems that we're talking about in Unit 3, we don't want to go ahead and solve any of these equations or factor anything until we have equations that are equal to 0. That is the case in all 3 of these, all right, so we don't have to worry about that side of it. And then once we have it equal to 0, then the next thing we want to check and understand is that we understand that factoring this out, making that standard form problem look like an intercept form problem would help us kind of a little bit quickly figure out if we have any, or if we can figure out what the solutions are to the equations. So I'll come over here, again it's equal to 0 already, so we're happy with that. Let me go ahead and check out the GCF here. Alright, so in this problem, the GCF, if there is any, we want to take a look at the coefficients. I got 3, 18, and 24. Any number that's divisible into those numbers, except for the number 1 of course, and in this case, each of those is divisible by 3. So my GCF here for the coefficients is 3. Then I take a look at each term, 3x squared, 18x, 24. I focus on the variable, see if there's any common thread when it comes to the variable. And there's an x there, and there's an x there, but there's no x for our constant 24. So that 24 does not have a variable within it, which means there's no variable GCF, which means GCF here would only be 3. I want to go ahead and take that out, factor that out so that I can go ahead and see what else is left over. So I'll pull it out, and when I pull it out here, I'll have 3, and what would be left over from that? 3x squared divided by 3 would be x squared, 18x divided by 3 would be 6x, 24 divided by 3 would be 8, and it's still equal to 0. So as an understanding here, we factored out the GCF, that's fantastic. I look inside that parenthesis and I see a quadratic still. So since I see a quadratic still, there's more to check here. It's not an intercept form. It's set, in fact, inside the parentheses here is standard form. So that just kind of is a little bit of a hint that I haven't factored this as completely as possible quite yet. So go ahead and now that we have a quadratic inside these parentheses and we have 1, 2, 3 terms. I'm going to look specifically within that parenthesis, and I'm going to look at the x squared, the 6x, and the 8, and I'm going to apply our ABC method here. So with that, as in previous videos, my A value is 1, my B value is 6, and my C value is 8, and I'm going to try to figure out, are there factors of C that add up to B? Factors of C that add to B. And in this case, factors of 8, I would have 1 and 8. Technically, -1 and -8 as well. Those both would multiply up to 8, and then finally 2 and 4, and -2 and -4. I believe that's it when it comes to whole numbers being factors of the number 8. Of those sets, do any of them add up to 6? 1 plus 8 is 9. -1 plus -8 is -9. 2 plus 4 is 6. That does in fact add up to B and also multiply to C, so we're happy with the 2 and the 4. What that gives me here is now it's going to take a look, and this that was in parentheses is now going to become intercept form, standard form to intercept form. So I have here x plus 2, x plus 4, still equal to 0. But let's not forget the 3 in the front that was our GCF. Now it has been completely factored. We can again tell the difference here. It was in standard form. It now looks like it's in intercept form. We just got to go ahead and apply that zero product property. Got to understand that we're doing the zero product property with all the factors, which is a weird thought here because technically 3 is a factor. In fact, it's the greatest common factor for this. So when we do the zero product property, we're checking out each of these factors. 3 equal to 0, x plus 2 is equal to 0, and x plus 4 is equal to 0. Hopefully we all realize that it is a completely incomplete statement. 3 is equal to 0 is not true. There's no variable there, so we're just going to go ahead and get rid of that. There's no variable to plug in there. It's just 3 is equal to 0. That's a false statement, so we're not worried about that. We do, however, have two solutions here. We have our x is equal to negative 2. And from this equation right here, x plus 4 is equal to 0, we would know x would be negative 4. Let's go ahead and try out number 2. Number 2, similar situation. Looks different though, definitely looks different here. We're going to try to solve this equation. I got x to the third power minus 13x squared plus 40x. And, you know, maybe right from the get-go you say to yourself, wait a minute, the biggest exponent isn't 2 anymore, it's 3. And that probably should, in a unit about quadratics, tip you off about something weird happening here. So, again, let's go ahead and check for a GCF. And we first look for the coefficients here. We'll look at the coefficients 1, negative 13, positive 40. Any numbers divisible other than the number 1 into those coefficients, and there's not. In fact, 1 and 13 are both prime. That's really a good hint that there wouldn't be a GCF when it comes to the coefficients. But we look at each of these terms and recognize that they do, in fact, each have an x value. So the greatest common amount of x values, here we have 3, there we have 2, there we have 1. They all have at least 1 in common. They all have 1 in common, so GCF here will be the variable x. And I'll go ahead and pull that out. X to the third power divided by x is x squared. Negative 13x squared divided by x is negative 13x. Positive 40x divided by x would be positive 40. And still equal to 0. At this spot, again, we stop for a second and we talk about the GCF and we get the GCF, but inside this parentheses here, it does not yet look like intercept form. In fact, inside the parentheses, it looks like standard form. So we've got to try a little bit of extra stuff here. We're going to go ahead and try out the ABC method once again. My A value is 1. It's a good way to figure that out, that at least we've got to give the ABC method a shot. In this case, my A value is 1, B value is negative 13, and my C value is positive 40. So again, I need to figure out, is there factors of C that add to B? Factors of C that add to B. And maybe you're already kind of thinking this way, but our B value here is negative. So if we take a look at 40, sure, we have 1 and 40, and there's actually a lot here, 2 and 20, 4 and 10, 5 and 8, I believe that might be it. But if I add all those numbers up, try to see if they add to B, 1 plus 40 is 41, 2 plus 20 is 22, 4 plus 10 is 14, 5 plus 8 is 13. They're all positive numbers, so we have to understand that we could also multiply by -1 and -40. -2 and -20 would give me +40. -4 and -10, -5 and -8. So again, going through that process there, -1 plus -40 is -41. It's not our B value. -2 plus -20 is -22, not our B value. -4 plus -10, very close, it's -14. That's not what we want though. -5 plus -8 would be two numbers that they would multiply to 40 and add up to -13. Excuse me. So I'll come off to the side here, and again, I got x minus 5, x minus 8. But once again, we have to be careful here to not forget the GCF that we took out originally in this problem. So I have that GCF out there. Now everything is factored out. It certainly looks, especially on the back end here in blue, like it's in intercept form. It's no longer in standard form with that quadratic. We have factored this as far as possible. Now let's go ahead and apply that zero product property. And again, even the GCF here, all the factors get set equal to 0. Now previously, 3 is equal to 0. That was a false statement. There was no variable there. We kind of just crossed it out. But here, x is equal to 0 is a perfectly fine statement. And there's not a lot of math work to be done. It's just x is equal to 0. So 0 here is actually one of the solutions to this equation. From the second one, x minus 5 is equal to 0, we would have 5, and then we would have 8 also. So there's here in this problem actually 3 solutions to the equation. We've kind of mentioned this in the past, and technically when we started here, the biggest exponent is 3, so it's not necessarily the most ridiculous thought that we have 3 solutions to this equation, where we know that it would be, if we took 0, 5, or 8, plugged it in here, it would be 0 is equal to 0. As my phone currently rings in the background there. Question number 3 here, I got 4x to the third power minus 4x squared minus 8x is equal to 0. So I'm going to go ahead and take that and plug that in.